All right, so number one, we have to use principal, the total amount, principal times e to the r times t power, the PERT formula, okay? Principal, remember, represents how much we started with, which was what? $10,000, right? Oops, there's one. And then E, and you'll put, second natural log to get that to be it. Remember, you need your caret there, so your E. And then what's our interest rate? Yeah, so we move it 2 to the left, right? 0.0525. And it was for 15 years, right? So T, our time, was 15. So we put that in our calculator. We go to 10,000. Second natural log to get our E, and then 0.0525 times 15. Close it up, and we get $21,978.95. Always go to the nearest cent when you're doing the money problems. Any questions? All right, just use that formula, right? 2 is the same type of problem, but they give us the formula for your account, and they give us a picture of the graph of your friend's account. Okay? I should have put that on here, but I didn't. That's okay. Put that graph. You guys can look at it. All right, so here's you is this account. So the 3,800 is our what? Our principal, right? Our initial amount. All right. Our interest rate is 5%, and T will be 15 years also for this one, won't it? All right. So when we find this amount, we might as well find this amount because we have to see who had the most, right? Okay. So if I hit second enter, I can change this. Let's delete that because I don't need that much. What is it? Oops, wrong way. 3,800, right? Got the E. Got the 0.05. We can delete the 2.5, right? Times 15. All right, so $8,044.60. That'll be the balance. This is number 2.
Do it.
Okay, so we have to do that anyway, right, to answer the question. And then the picture of our graph, I'll try to. It looks kind of like this. It's almost a straight line, but it's starting to curve a little bit. And this point here was 4,200. And over here at 15 years, if we go up and then over, that looked pretty close to $7,000, right? All right, so let's answer the questions. It says the graph shows the balance of your friend's account over time. Which account has a greater principal? Okay, so here's the principal for your friend. Here's the principal for you. So So who had the greater principal? Friend, right? And the other question was, which account has a greater balance after 15 years? Which one of these is bigger? 7,000 or 8,044.60? The 8,000, right? So this had the greater balance. U. Make sense? You understand how to read the graph? How to find the balance? Pretty easy problems, right? All right. 3, 4, 5, and 6. We're rewriting in the other form. So if it's given to you in exponential form, you're supposed to write it in logarithmic form. If they give you the problem in logarithmic, you write it in exponential. Okay? So this was an exponential. 5 squared is 25. So in logarithmic, that's log base 5 of 25 equals the exponent, which is 2. Right, Vince?
Yes. I'm playing around for good reason.
No good reason.
I think you're tired. I think you're tired.
All right, this one, number 4, is in logarithmic. So what's the exponential form of that? 4 is the base, 3 is the exponent, equals the number 64. You guys are good at this. We shouldn't miss any of these, should we? Okay, but number 5 tricked some of us. This was natural log, another logarithmic form, equals 4. Remember, natural log you could write like this. Log base e, that's what it means. Okay? So in exponential form, what's the base? E. What's the exponent? 4. What's it equal? The number, which in this case was x. All right? So natural log means the base is 4. I lied. The base is e. Sorry. What if it was this? Just for another example. What's the base? 10. Very good. Right? If no base is written with your log, then it's 10. So this would have been 10 to the 4th is x. Okay? So maybe tomorrow instead of ln, I might just have log with no number. Okay? All right. Number 6. 2 to the 5th is 32. So writing it as a logarithm is log base 2 of 32 equals our exponent, which is 5. All right, so again, we should not miss any of those, right? Pretty easy, right? All right, then the 7 through 10 was evaluating without the calculator, what we taught you, right? So we've got log base 4 of 4. Okay, there's nothing else written. What makes this easier? Equals x, right? Always put that in. So rewriting it like we've just been doing, what's this exponent that we never write? 1, right? So that means my x equals 1, right? So once you get it written with the same base, you just set your exponents equal. Since my exponent's x equals 1. All right, some of you were stopping. Just wrote 4x to the 4 to the x equals 4, or I'm sorry, yeah, 4 to the x equals 4, but didn't tell me what x equals. So make sure tomorrow you write x, whatever x equals, okay? Or if you do it like me, just square around them, that's okay. Or that's a rectangle, I guess. Okay? Now, something else you could remember, when the base and this number are the same, what's the answer always? 1. Now, next week we'll get into some more log stuff. You'll get some problems where they'll go log base 4 of 4 and they might put a 2, 3, 4 or something there. Okay? So if there's an exponent with the 4 here, then that's the answer. Okay? So if it was log base 4 of 4 squared, the answer is 2. If it's log base 4 of 4 to the 10th, the answer is 10. Okay? Just something that we'll talk about next week. All right, number 8, log base 3 of 127. Remember, right equals x. Okay? So then we rewrite it in exponential form. 3 to the x power is 1 over 27. Okay? So we want to try to write this 27 with a base of 3. Well, that's easy to do. It's 3 to the what power? Third. Right? But what do we do when the 3 to the third's in the denominator, Mason? Yeah, I want to move it to the numerator. What happens to that exponent? All right, this is what we started with. We rewrote it. The 27 is 3 cubed, but it's in the denominator. We want to put it up in the numerator. What happens to that exponent? William, what happens to that exponent when I move it up? Jordan, what happens to this exponent when I move it up?
It becomes negative?
Yes. Okay? Don't forget that. All right, so my answer then is not 3, but it's actually negative 3. X equals negative 3. Okay, on those fraction ones. Number 9, log base 2 of 16 is the problem. Again, we write equals x, and then we rewrite it in exponential form. Can I write 16 with a base of 2? Yeah, it's 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16, right? So what's my answer? 4. Okay? And the last one. Log base 5 of 625. Remember, we add in the equals x. So we rewrite it as 5 to what power is 625. Can I write 625 with a base of 5? Yeah. 5 to the what? 4. So that means x is for number 10 also. Okay? So I have a extra practice worksheet that you can do, you don't have to do. But if you do it, you get some extra credit. Okay? So I'm going to pass that out to you. It's your choice. All right? I'll make it 5 summative points. Extra credit. Okay? You do not have to do 15, 16, 17, or 18. You can cross those out.
Do we have to take one?
Oh, no, you don't have to take one again. You're welcome.
I don't know.
You don't have to do. Okay?
So 0.4 meters. That's 0.4 meters. That's what you mean?
Yeah. I forgot what it was.
Wait, which ones is it? It was
15, 16, 17, and 18 you don't have to do.
15, 16, 17. Right then.
Yeah, 15, 16, 17, and 18.
Yeah, cross out 15, 16, 17, and 18.
And 18. Wow, that's crazy.
Yeah, we didn't worry about graphing.
I already got one.
Oh, okay. Thanks. The bottom part there, those numbers 1 through 8, is from 6-2, even though I didn't put any of those on
Go.
the quiz. You can still know how to do those.